Next, we do addition and subtraction with mixed numbers. And again, there's no new properties or rules to follow. We're just going to improvise with what we already have. So let's see what happens if we want to add 2 1/5 and 3 3/5. It looks like we should be able to add the whole number parts and the fraction parts separately and get the result. But just to be sure, let's use our definition. This is going to be 2 plus 1/5 plus 3 plus 3/5. If we just use the meaning of this notation, 2 1/5, as 2 plus 1/5, and the meaning of this notation of 3 3/5 as being 3 plus 3/5. Now you can see with the commutative and associative properties, this is going to be 2 plus 3 plus 1/5 plus 3/5. So I do in fact add the whole number parts here and get 5, and then add the fractions and get 4/5. And so that gives me 5 4/5. So I see that I can add mixed numbers by adding the number parts or the whole number parts and then adding the fractions separately to get my result. Let's look at our next problem. I have 6 1/2 and 2 5/14. Let's see, I have a common denominator here with 2 14 of 14. So I'm going to rewrite this as 6 and 1 over 2 times 7, 1 times 7 over 2 times 7, so I get that denominator of 14, and this is still 2 5/14. So that becomes 6 7/14, and this is 2 5/14. Now I'm just going to add separately. 7 and 5 is 12 14, and then 6 and 2 is 8. So I end up with 8 12/14. I can reduce the fraction part down to 6/7. So 8 6 over 7. So that seems like a pretty workable method right there. We simply add the fraction part and add the whole number part separately. If the fractions don't have a common denominator, we have to change two equivalent fractions that have the least common denominator. Then we add and just do things like we normally do. Here's another problem. 5 4/10 minus 3 1/3, so it's a subtraction problem. Again, I look for the least common denominator. The smallest number divisible by 3 and by 10 is 30. So I'll rewrite this as 5, and let's see, I'm going to have to multiply 10 by 3 to get 30, so I'll do the same thing to the numerator. And this will be 3, and I'll multiply that denominator by 10, so that numerator by 10 also. So I'm changing to equivalent fractions. This is 5 12 30ths, and this is 3 10 30ths. Now I'll do my subtraction. 12 30ths subtract 10 30ths is going to be 2 over 30, and 5 subtract 3 is 2. Changing that to a mixed number that has the fraction part in lowest terms, it's going to be 2 1 over 15. So 2 1/15 for that. So it works the same with subtraction. I simply have to find that least common denominator, change the fractions to equivalent fractions that have that least common denominator, and then I'll just subtract as usual. Let's look at another problem. 8 minus 1 3/4. Let's set this up vertically. So I have 8 subtract 1 3/4. Well, here I want to subtract the fraction parts, but there's no fraction here. I'm going to do something similar to what I did when I did borrowing with regular whole numbers. I'm going to borrow 1 from that 8, leaving it as 7, and the 1 I'm going to write as 4/4. So isn't that true, though, that 8 is the same as 7 4/4? Because 4/4 is 1, so 7 plus 1 is the same as 8. So I haven't really changed the problem. I've just changed the form of it. Now, 4/4 subtract 3/4, that's 1/4, and 7 subtract 1 is 6. So that result is 6 1/4, and I did something similar to what I used to do when I did borrowing with whole numbers. So let's try another problem that's going to involve that same thing. 9 2/3 subtract 5 3/4. Okay, let's write this vertically. 9 2/3 subtract 5 3/4. Okay, the least common denominator is 12, so I'm going to write this as 9, and let's see, I'll multiply 3 by 4 to get 12, so I'll do the same thing to that numerator. This will be 5 3/4. I'll multiply that denominator by 3, so the same thing to that numerator. Now I end up here with 9 8/12. Subtract from that 5 9/12. So look, I can't subtract 9/12 from 8/12. So what I'm going to have to do is borrow 1 from this column right here in terms of 12ths. So I'm going to borrow 12/12. I'm going to add that to the 8/12 I already have. Let's rewrite the problem down here now as 8. So I borrowed 1 from this column right here. So now it's an 8. And what I did is I added on 12/12 to this 8/12. So instead of 9 and 8/12, I have 8 and 12 plus 8 is 20/12. Subtract from that 5 and 9/12. So 8 and 20/12 is exactly the same as 9 and 8/12, and I had to do that borrowing. What did I borrow? I borrowed 12/12, which is the number 1. 20/12 subtract 9/12 is going to be 11/12, and 8 subtract 5 is 3. So the answer is in lowest terms 3 and 11/12. So there is a look at kind of a difficult kind of subtraction problem with mixed numbers, but we seem to be able to survive it by doing that borrowing, similar to what we did with whole numbers.